Hello students, your teacher here, Mr. Shirasinski's episode of Geometry Transformations, and today in this video we're talking about dilations. Starting out, we got a little warm up here. It says describe the two transformations pictured below, write the ordered pairs for the 4 points marked. So 1 and 2, what is happening? What is the transformation? 1 and 2. So this is your pre-image. This is your image. Pre-image. Okay. And then A, B, C, and D. What are those points? Pause the video. See if you can name those transformations and those ordered pairs. Okay, so I'm assuming you paused the video. For the triangles, the transformation for number 1, just come over here, that would be a reflection over the y-axis. For the second transformation, we'll just call that maybe A, so 1A. For B, it looks like our squares got translated. I don't think this is a reflection. I think this is a translation, and I'm just going to follow this point. A translation 5, 6, 7 to the right and down 2. So we would say x, comma, y, such that x adds 7, y subtracts 2. All right, now my ordered pairs. A is at -2, 4. B is at 5, 4.
Attention staff.
Sorry about the announcement. C, -3, -4. And D, 1, -2. All right, so today we are learning about dilations and how to dilate a figure and how to calculate the scale factor. Okay. And towards the end of the lesson, we're going to perform some two-step transformations and talk about glide transformations. Okay. So a dilation is a transformation in which a figure is enlarged or reduced, and this is critical information. It is the only transformation that is not in isometry or rigid motion because the size changes. Okay, so if you multiply every coordinate of a figure by a number, if it's greater than 1, it gets bigger. If it's less than 1, it gets smaller. So if it's getting bigger, we call that an enlargement. And that means that the scale factor is bigger than 1. And I think if you think about this, it makes sense. When you multiply something by 1, you get the same number. So if you're multiplying by something more than 1, it should be bigger. You should be making the number bigger. And if you're multiplying by a fraction, you should be making the number smaller. Okay. All right, so if we're determining scale factor, first we need to determine, is this an enlargement or is this a reduction? And all you have to do is pay attention to, in these diagrams, we don't see it as much, but in your diagrams on your homework, you will see like a P and then a P prime. And so it will be obvious if it is growing or getting smaller. In this example, it looks like our original is P, and then it looks like it gets bigger. And so maybe not. Maybe that one's getting smaller. Okay, so yeah, this one is getting bigger. All right, so for the first one, it's an enlargement. So this is an enlargement. And anytime a number is, or a shape is getting bigger, we multiply by something more than 1. So I know that the bigger number needs to go on top. So the scale factor would be 15 over 6. And I can reduce this fraction. And so 15 over 6, that both reduces by 3. So you just divide them by 3 and you get 5 over 2. On your calculator, if you're terrible at reducing fractions, go to your calculator, type in 15 divided by 6, hit math, and then enter, and that will your calculator will reduce the fraction for you. All right, so my first scale factor is 5/2, and then we're going from 1 to 2, so small to big, it's getting bigger. So I have the whole thing over the original. And that will both reduce to 5 over 3. Okay, let me double check, keep going. Determine the scale factor on a graph. Identify the pair of corresponding sides. All right, so in this example, you can see very clearly what our original was and what our new one was by the notation with the points. So A and then A prime. So I know this is my pre-image and this is my image. Okay. So clearly we're getting bigger. So this is an enlargement. Now, corresponding side would be like AB and AB. And the little AB is 2 and the big AB is 4. And if it's an enlargement, we always put the bigger number on top. And when we do a reduction, you guys will see that we always put the smaller number on top and the bigger number on bottom. Okay, so we're putting, this is an enlargement, so the bigger number goes on top. 4 over 2 is 2. Okay. All right, dilations in the coordinate plane. Graph triangle ABC and then dilate it by a scale factor of 2. Label the new vertices. If we're dilating this by a scale factor of 2, it's an enlargement because we're multiplying by a number that is greater than 1. All right, so first let's graph it. 0, 0, there's A. 2, 1, there's B. And 0, 2, there is C. Draw my little tiny triangle. Okay. Now we will need to dilate this by a scale factor of 2. And what that means is you multiply every coordinate by 2. So for A, if we have 0, 0, and we're multiplying it by 2, we would have still at A prime now 0, 0. For B, at 2, 1, we're multiplying by 2, we would have a B now at 4, 2. So every coordinate gets multiplied. And C was at 0, 2. When we multiply it by 2, we get 0, 4. Okay, now I'm going to plot my new triangle. 0, 4. 0, 0, and 4, 2. What you should notice is that these have the exact same shape, but one is larger than the other. One thing I want to point out and remind you guys is that the angles do not change when you dilate a figure. So these angles in the smaller triangle are the same as their corresponding angles in the larger triangle. but the sides are not the same, side lengths. Okay. All right, so now we have a square, and we're going to dilate it by a scale factor of 1/2. So, all right, sorry about that. I just paused for a second while I was drawing my square, and now I need to dilate it. So all of these ordered pairs are about to change. A was 4, 4, and we're multiplying by 1/2. So now A prime is 2, 2. All right, B was negative 4, 4 times 1/2. Now B prime is negative 2, 2. All right, C was negative 4 times 1/2. C is now negative 2, negative 2. And last one, D, negative 4, negative 4. Wait, no, D was, sorry about that, positive 4, negative 4. And times 1/2, D prime would be at positive 2, negative 2. All right, so let's graph our new square. And this is clearly a reduction. And so 2, 2, there's A prime, D prime, C prime, and B prime. Connect the dots. Okay. All right, so now the function notation for dilations. Dilate triangle ABC by xy such that 3x, 3y. And so if we're multiplying each coordinate by 3, that is definitely an enlargement. And so we just need to multiply each one of these by 3. All right, 1 times 3 is 3, 3 times 3 is 9, 2 times 3 is 6, 6 times 3 is 18. That one is not going to fit. And then negative 3, positive 3. All right. So pause for a second. I'm going to graph the pre-image, and then I'll come back and graph the image. All right, so there's the original triangle. Sorry, it looks a little wonky. Now let's go ahead and graph our A prime, B prime, C prime. So 3, 9. 6, 18, way up there. 6, 18. I'm going to say somewhere around there. And then C, negative 3, positive 3. Okay. All right, not perfect, but you can see how this works. All right, next. Graph the pre-image and the image on the coordinate plane below, label them accordingly. Dilate triangle ABC, and this time we're dividing by 3. This is like multiplying by 1/3. And since we're multiplying by a number less than 1, we're reducing the size of the shape. And so I'm going to pause and plot ABC. While I do that, you guys go ahead and multiply each of these coordinates, or divide by 3 or multiply by 1/3. Write down your new A prime, B prime, C prime, and then let's graph it. All right. If you think you know what to do, pause the video. Do it. All right. I have calculated my 3 new points for my image, and I'm going to graph them. Negative 2, negative 1. That's my new A prime. 2, negative 2. That's my new B prime. And negative 3, positive 3 is my C prime. Okay. And we got a nice little triangle nested inside the other. How wonderful. All right, next slide, brain break. We don't need that. Let's keep watching. Multi-step transformations. Anytime that you have a reflection and a translation, whether it's reflection first and then translate, or vice versa, this is called a glide. And you just need to know that. That's a glide reflection. But as long as you know how to perform each one, the glide doesn't really matter a whole lot. You just a term for this type of transformation. And so in this example, we're being asked to reflect over the y-axis. So I'm going to go ahead and draw some attention to my y so I can start counting. And I know how far to count on the other side. And then after I perform my reflection, I'm going to translate the image. All right, so we're going to have two more triangles. All right, let's redo A. A is 2 away, so there's A prime. C is 2 away, there's C prime. And B is 4 away, so there's B prime. Okay, so we performed the reflection, and now down 5 units. So 1, 2, 3, 4, 5. C double prime, A double prime, and B double prime. And that is your first glide reflection. A reflection and a translation. And it doesn't matter the order, it's called a glide. All right, let's perform another glide transformation. You guys try this one. Pause your video and then turn it back on and check. All right, in this example, I'm being asked to reflect over the x-axis. So I'm gonna do that first. You can see my triangle has now been reflected. I drew attention to the x-axis, and then I just counted how far away each point was, and then I counted that much on the other side. So our first, if we were gonna write a rule for this, we would say, let's see, reflected. Well, what happened to the ordered pairs? So B was 4, 2, and it became 4, -2. So that looks like the y value just changed to its opposite. So x, comma, -y. Okay. And then we want to perform a 5-unit left translation. So that would be x minus 5y. All right, now let's go actually do it. Here we go. 5 units left for all the x values. So C, count 5 to the left. There's C double prime. A, 5 to the left. Oh, wait, I think I went 6. Jeez. All right, let's try again. 5, there we go. C double prime. A double prime. And then B double prime. Okay. That is your other glide reflection. Next. Last one. Complete the transformations below to square A, B, C, D. Label the final figures ordered pairs. Okay. So our pre-image, let's go ahead and write down the ordered pairs. We've got A at 2, 7. We've got B at 2, 1. C is at 8, 1. And D is at 8, 7. Okay. Now, first, it's asking us to perform this translation. So let's go ahead and calculate our points and then graph them. If we're translating minus 10 for the x values and minus 3 for the y values, I just need to perform this numerical operation on every ordered pair up here. Okay, here we go. 2 minus 10 is -8, and 7 minus 3 is 4. 2 minus 10 is -8. 1 minus 3 is -2. 8 minus 10 is -2. And 1 minus 3 is -2. And 8 minus 10 is -2. And 7 minus 3 is 4. Okay, now I'm going to graph these. I'm going to pause the video for a moment. And go ahead and pause yours and graph. Practice. All right, so there is my first image after my translation, minus 10, minus 3. And now I'm being asked to perform a dilation. And this, since we're multiplying by 1/2, is a reduction. So I'm making all these ordered pairs smaller now, and I am multiplying by 1/2. So let's do that. Let's find our ordered pairs and then plot them. So -8 times 1/2 is -4. 4 times 1/2 is 2. -8 is -4. -2 is -1. -2, -1, -1. -1, +2. All right, so I just multiplied all of those previous coordinates by 1/2. Divided them by 2. All right, -4, +2. -4, +2. -4, -1. -1, -1. And -1, +2. And don't let me forget my symbols. And I'm going to be picky about this with you guys as well. So if you have not been making your marks like you're supposed to, please start doing that now. Your homework assignment is this one. Let me just double check and make sure this is what I assigned you. Yes, 1 through 4, 13 through 21, and 23 through 28. There should be plenty of graph paper. Please get these done, and please do the graphs. They're so important, and you will have to do them on your test, so get familiar with them. I am your teacher. This is the way.